Okay, we're going to continue on with lesson 2.5 on applying the remainder and factor theorems. So this is how we are going to use division to help us solve and or factor our polynomial functions. So the first thing what we want to look at is polynomial long division. So you'll notice that we have a function, f of x is equal to 3 times x to the 4th power minus 5x to the 3rd plus 4x minus 6. And we're dividing that by x squared minus 3x plus 5. So our solution is we are going to write the polynomial division using the same format of long division as when we have numbers. And then it says to include a 0 as a coefficient of x squared in the dividend. So similar to synthetic substitution, we need to account for all the exponent place values. So since we skip over from x to the 3rd to x, and we skip over that x squared, we need to include that 0 there as the placeholder. So at each stage, we're going to divide the term with the highest power in what is left of the dividend by the first term in the divisor. And then that will give us the next term in our quotient. So let's take a look at how this looks. So long ways out, so I'm using a new format so it just gives us all of the answers at one time. So let's take a look going step by step. Now I can control the arrow. So we have our long function here, the one that was our dividend. And notice we have the 0 as the placeholder, and here's our quadratic divisor. So we want to divide 3x to the 4th power. Well, what of x squared can go into 3x to the 4th power? And that's 3x squared. So we are going to put that into the column that is for x squared. And then we're going to multiply that out to all of the terms so that we get our subtraction. So then we subtract this line to make sure everything is the opposite sign of what it should be because of the subtraction. And then we are going to, from there, we have a new line, bring down all of the parts that we need, so you bring down the next term, and we are going to divide 4x to the 3rd power by x squared. And when we do that, we get the next term of 4x. Multiply that out, so we get this next line, subtract, and we get negative 3x squared minus 16 minus 6, so we're going to bring down that negative 6 term. Multiply what we need to, divide negative 3x squared by x squared, which gives us 3. Divide all that out, multiply all that out to get our subtraction, and we are left with negative 25x plus 9. And this is our remainder. So once we have the quotient and we have the remainder, we can, oops, I did not mean to do that. Once we have the quotient and we have the remainder, then we will have our solution. So here was the division problem, here was the quotient plus the remainder. And we always put the remainder as the numerator over the divisor as the denominator. So this becomes our fraction answer. Notice that this is the same thing as what we were dividing by. That's the divisor. And then you can always check your answer by using multiplication. We're going to multiply the two quotients and then add back in the remainder. And that would check your answer for you. So let's take a look at another long division. This time we have a linear divisor, so nice and easy. Set up our problem. We have x to the 3rd power plus 5x squared minus 7x plus 2 divided by x minus 2. So the same process. We want to divide the highest term by x, figure out what is needed, multiply it out, subtract, bring down the term, divide the next term, 7x squared by x to get 7x, multiply it out, subtract, bring down the next term, 7x divided by x, so 7, multiply it out. Eventually we end up with just our remainder. And then set that up in our fraction form. So here is the quotient that you can see in the quotient line, and then plus 6 over x minus 2. All right, synthetic substitution. I like this much better because, again, you don't have to worry about keeping all those terms in order and having so much space. If you can just keep your little synthetic division area nice and clean, this is much easier. It's the same process of where we go through and use synthetic substitution to get our solution. But this time, these numbers down here represent something new. So we had this in order of x to the third, x squared, x, and then no x. When we're left, the order is not quite the same. The last term is our remainder. Then the next to last term is 0x, 1x, x squared. So notice that now we take this and say it's 2x squared minus 5x plus 7 minus the remainder of 16 over x to the third. So a couple of things to point out. Notice that we have x plus 3 here, but we put negative 3 here. Because the solution, if we're using synthetic substitution, that means the solution to x plus 3 equaling 0 is negative 3. So we want to use the opposite of whatever the constant is when we substitute it in. Gets easier with practice. Let's take a look at another example. So we're going to factor this polynomial. And we know already going into it that x plus 2 is a factor. So we have this polynomial function and we want to factor it. And we already know that we have this as our solution, as one of the solutions. So because x plus 2 is a factor, we know that f of negative 2 equals 0. So we're going to use synthetic division to find the other factors. So go ahead and substitute in negative 2. Go through the process of synthetic substitution. You should get a remainder of 0. That tells you it's the factor. If you don't get a remainder of 0, then it's not a factor of, it's not a solution to the polynomial. So now we're left with 3x squared minus 10x minus 8, remainder of 0. So our next step is to take that quadratic quotient and factor that out. So you would continue to use factoring techniques that we did back in chapter 1, or you could also continue to use synthetic substitution by thinking of some possible solutions already. If you knew that 4 and 2 are going to be factors of 8 as well as 1 and 8, you could try substituting in 1 and 2 and 4 and 8 until you got a solution. But look at the factoring ones first. This first part of the lesson is going to be pretty easy with this, so keep it nice and simple. I'm only showing you this example because you will see multiple choice questions occasionally, so I do want you to have a little bit of exposure to it, but also because I want you to reinforce this idea that how do we use synthetic division to help us factor out a problem and find other solutions. Notice the question says, what's another 0 of f? So it tells us that x is equal to 3. That means we're going to use positive 3 here. And x minus 3 was the factor. So substitute all of our terms in, 1, negative 2, negative 23, positive 60. Multiply it all out. Of course, we get a remainder of 0, which is what we wanted. And here we have x squared plus x minus 20. So once we have that remainder, x squared plus x minus 20, we're going to factor that. And so we have x plus 5 and x minus 4, meaning our solutions would be negative 5 and 4, plus the 0 from before. And then we wanted to look at what possible answers there were. We had negative 5, negative 4, 2, and 5. And the only one that is of this list that is a solution was negative 5. So you'd bubble an A. Nice and easy. Let's take a look at our word problem. All right, so it tells us, the problem says, the profit, P, in millions of dollars for a shoe manufacturer can be modeled by P equals negative 21x cubed plus 46x, where x is the number of shoes produced in the millions. The company now produces 1 million shoes and makes a profit of $25 million. But it would actually like to cut back production, so it wants to make less. What's a lesser number of shoes that the company could make and still make the same profit? So let's set up the equation. So the solution was y was equal to 25 because it was $25 million, and P stood for the profit in millions of dollars. And then, so we have this equation, 25 is equal to negative 21 x to the third power plus 46x. Rewrite it so that it's in standard form, equaling to 0. Now it told us in the problem that with 1 million shoes, We already know it gives us $25 million. We want to find another possibility. So we're going to substitute in 1 using synthetic substitution or synthetic division. So we have our equation here. Remember to put in a 0 for the x squared spot. Go through the process of synthetic substitution, get a 0, which is what we were expecting. But the key part is here's our new quadratic equation. So 21x squared plus 21x minus 25. So now we're going to take that, and we can't factor it because it's not factorable, but we can use the quadratic equation. The quadratic equation always works. So negative b plus or minus the square root of b squared minus 4ac all over 2a. And we get, when we solve that, we get the positive and negative versions. And so we want the positive, since obviously we can't make negative shoes. So x is approximately 0.7, so that would be 0.7 million, which is about 700,000 shoes. So if the company produces 700,000 shoes, it's going to make the same profit as if it were to make 1 million shoes. So a lot less work for less shoes. I think that's a good idea. So that's it for lesson 2.5, and we'll do some more practice in class. Please come with questions.